Hello all and welcome to this quick demo of the NTT Data Migrator. The Data Migrator is part of the NTT Data Suite, which is a combination of three accelerators that help you with your cloud migration journey. The Migrator helps you migrate your data from source to modern cloud data warehouses. It has both ODBC and file-based mechanisms to extract the data from your legacy databases. It is a collection of composable data transport modules designed to incrementally move your data from the source to the cloud data systems. At a very high level, the accelerator can be deployed on a virtual machine in your cloud environment. This can be with a Linux or a Windows machine. And since the accelerator has been written in Python, the installation is pretty straightforward. The data migrator executes as two parallel processes. The first being the extract from the source to an object storage, and the second being the import from the object storage to the cloud data warehouse. These two processes are stitched together using the state management tables that keep track of the entire process in an easy-to-query set of tables in the cloud data warehouse. These asynchronous processes maximize the throughput on extraction. Additionally, the tool also has capabilities like iterative logic based on size of the table to accommodate limitations with available spool space on the reader account and pick up from where the last iteration stopped. Database CDC with an ability to track multiple columns, even if they are different columns that are used in subsequent iterations. It also addresses data challenges like duplicates, encoding, and trimming of white spaces based on configuration and verbose logging in terms of state management tables and log files. As part of the NTT Data Cataloguer, we migrated schemas to Snowflake, and the documentation referred here mentions the target as Snowflake. But for this demo, we will be looking at an example for migrating your data from SQL Server to Databricks with visualizations built in Streamlit. Now that we know about the capabilities of the tool, let's take a quick look at it. For this demo, we'll be using a SQL Server database with just one table as of now. And this has about 1 million records that we'll be moving into Databricks. On the Databricks side, we've already created the schemas using the Entity Data Cataloguer. So the table already exists there. Currently, this table does not have any data. The UI for the migrator is similar to what you saw on the Entity Data Cataloguer. As expected, you have connection settings for the source and the target. Additionally, there's a staging directory where all the logs would be created. The data is extracted from the source system and pushed into an object storage. You can mention the path of the object storage here on the UI. The target that we have set here is pointing to the same Databricks instance that we just saw. Additionally, as mentioned before, we are also maintaining the state manager tables on the target side itself so that it can be easily queried and dashboards can be created on top of it. Once the source and target connection settings have been configured, we can fetch the inventory from the source side to take a look at what all tables are available to be migrated into the target. As this is a test system, we have just one table which we just saw on the SQL Server. In addition to the table name, you also get certain metadata like row counts, the table sizes, when a table was last accessed or modified. This helps you to prioritize whether or not you want to migrate a particular table. Additionally, you can specify the encoding that needs to be used when ingesting the data into the target system. The watermarks can be used for any subsequent CDC-based iterations. This is dependent on the mode that you select. The full mode would truncate the data on the destination side and do a full migration of the table from the source. Merge refers to CDC so that it picks up data only after the last iteration. So anything which has changed from the previous iteration will get picked up in the subsequent iteration. Delete insert helps you delete duplicate data if it exists in your source system based on a set of keys, which can be put into a particular configuration table, or the tool can also identify the keys directly based on the primary keys of the table in your source system. The incremental mode helps you to migrate the data in an incremental fashion for cases where you have a limited time available on the source side for the migration. So if you have a downtime on your source side for say 12 hours over a weekend, and you run into a scenario where your iterations and migrations are still in progress, but you have to kill it because the business has come back and has to start use the existing system on the source side. In that case, you can kill the job on the data migrator. And if you set the mode to incremental, the next time it'll automatically pick up the iterations after whatever it had already extracted. Once we select which tables we want to export, we can simply click on migrate. The first check that it does is to check the connection settings. So it's going to go out to SQL and Databricks and the state manager's connections to see whether or not it is able to make the connections. Internally, it creates a couple of configuration files, and all the logs are maintained as part of the Streamlit UI itself. As mentioned, these are two parallel processes. So you have an export log section, and you also have an import log section down below. These logs are being streamed directly from the staging directory that we mentioned in the connection settings. So if we go back to the file system, this is the part that we had mentioned as part of the connection settings. So you would find a folder for the source here, and within that, individual folders for the tables. We picked up this employees table to extract. For each iteration of the table, you'll have a time-based folder, and the logs for those particular iterations get tracked in the logs folder. So let's look at the latest log that has been created. This mentions that it has extracted the data and dumped close to 1 million records into an S3 bucket based on the path that we had provided. Once the data is available to be imported on the destination side, the process for the import starts. So if you go back here, since this mentions that there are no entries available, the process automatically sleeps for 60 seconds and wakes up again to begin the import. So now it has found that entry in the state management tables and will start importing this into Databricks using a standard storage integration and a copy into query. Let's give it just a second to finish, and then we'll take a look at the data on the Databricks side. So now that the data has been migrated into Databricks, let's also take a look at the state management tables. We have two tables, one at a summary level and the other at a detail level. The summary level table maintains the entire state of the pipeline or the job at a summary level in terms of the table name and the number of iterations that it's going to take. Based on the size of the table, we can automatically, in a configurable manner, force the pipeline to run into iterations instead of doing a one big bang approach of selecting the entire data in one go. In this case, since this was just a small table, it has determined automatically that it needs just one iteration. And the iteration, although it has not completed yet, if we probably select this again, the process would have gone through and finished execution. So it has already completed this iteration. Now, once the iteration is complete, let's take a look at the detailed level view as well. As mentioned earlier, each job in the pipeline is going to be a set of two parallel processes. So for each iteration, you're going to find two separate processes, one for the extraction from the source side and the other for the import into the target. As can be seen here, we have two records here. One is a pull where the source is SQL and the sink is S3 in our case. The second is a pull from the object storage into the target system. So the source on the second record is the S3 source and the sink is Databricks. These two records can be stitched together using the correlation ID of the first record being the correlation ID in for the second record. Additionally, we keep track of the source entities, which is the table name on the source side. The source on the second step becomes the S3 location where we had dumped the data after extraction. We had picked hire date as the watermark, so it keeps track of this as the last record pulled for that particular column. One thing to keep in mind that we can track multiple columns in subsequent iterations. So in the next iteration, when you want to do a CDC, the hire date column gets automatically selected because that's the first iteration. But say in the second iteration, you find out that you need additional columns to keep track of changes, you can simply add it in the configuration and we'll automatically pull the max records out so that only the data that is changed or updated or inserted after the previous iteration gets selected on the subsequent iteration. Additionally, we maintain all the sourcing and syncing times so that you can derive metrics, which we'll see on a dashboard shortly. And for each iteration and each step, we maintain the row counts on how much was extracted and how much was imported. Since we maintain all of this information, what we can also do is create a very simple dashboard like this one on top of the data that we are already collecting. So this dashboard gives you a very quick overview of the overall status on where the overall pipeline and the jobs are. If your teams are looking at this in a day-to-day approach, you have a good distribution on how much was completed, failed, or is in progress day over day. We get a good sense of the export times based on tables so that you can very easily derive a nuance later. If business asks you, how long is it going to take to extract the data, you would have some sense of it. Similar to the export, we also maintain the import time on how much time it is taking to import from the object storage into the target system. We also have box plot distributions so that you're aware of outliers as well as the median time it takes to export or import. And as with any migration, we also keep track of all the record counts across time so that you always know how much was exported and how much is still remaining. So this was a very quick demo on the NTT Data Migrator. It's an easy to use tool, very easy to set up. With that, I hope this was useful for you and we'll be happy to help you with your cloud migration journey. Thanks a lot.